I'm Matt Mombrea, CTO and partner at Cypress North. I've been a software engineer for over 20 years, working on hundreds of projects across enterprise, startups, and many more.
Hey, and I'm Jonathan Nalewajek, and I'm a senior software engineer here at Cypress North. I've been with the company for 14 years, working on all sorts of projects.
Things have changed a lot over the past several years. It's been kind of a wild time with the advancements in AI, how things have been going, the improvements in tooling especially. And one thing I kind of want to talk about right out of the gate is this whole it's over mentality for software engineers. It's not, it's kind of shifting. And, we've kind of faced this situation forever in software engineering. And together, we've been doing this for a very long time, probably a third of the entire software engineering profession. We've kind of lived through it and seen tons of it. And way back when it was, things like low code tools, it's over. There's not going to be software engineers anymore. Generation 4, Generation 5 languages, we're not going to need developers anymore.
All the website builders,
right?
Not going to need developers anymore. Yeah,
exactly. Yeah, Wix comes out now. Web development is dead. Designers are dead. This has not happened. So it's not time to panic. I really don't think it is. It's just we need to adapt with the times, like we always have over decades of doing this work. And what's also become clear is that with each of these innovations and changes in our profession, we've needed developers more. We've not needed them less. And in fact, we've needed a big skill upgrade across the board where it's only the lowest level people who are kind of being trimmed out of the market. But anyone who's a good engineer, people with a lot of experience, have become more and more valuable with each of these new inventions over time.
Yeah, and especially with the current state of where the AI tooling is, you really need experienced engineers in order to guide the AI to get some of the results you're looking for. And without that core understanding and that core knowledge, it's tough to get a result that really speaks well.
Absolutely. And on that point, one of the biggest shifts over the past few years has been, in 2023, 24, AI was really a chatbot. OpenAI came out and mainstreamed this AI concept with a ton of hype, a ton of marketing, way overblown predictions and promises, but it made it so that everyone in the world knew what AI was or thought that they knew what AI was. And it did that by making it a conversational tool that was accessible to anyone. And you didn't need to know anything about it or how to use it. You just talked to it like a person, and it gave you kind of these magical responses that people have come to associate with AI. But what's happened recently is that in 2026 especially, it started probably in early 25, we've had this transition into agentic AI is what it's being termed. And the difference is that it's still powered by the same large language model, LLM, as a chatbot, but it puts in place controls that let it iterate on itself and form a loop where it's basically talking to itself over and over again and performing multi-step tasks on its own that makes it feel like a completely different type of tool for software engineering today.
The generative AI models of 2023, 2024 were cool and they inspired a lot of people, but it really was just, as you said, a chatbot. And now these new agentic models are still powered by that, but they talk to themselves. They can kind of problem solve together. It's just kind of a new way of using that same technology to come up with some new cool and exciting results.
Yeah, and I kind of oversimplified it, obviously. This is all extremely complicated. There's a lot of science that goes into it. It's very impressive stuff. And it's easy to get swept up in the hype of it as well. But knowing what we know, like understanding software design, software engineering at an extremely deep level, it kind of takes that magic away for us and probably for anyone else in the software engineering industry that's been around a while. But what's really cool about the agentic AI is that in addition to performing multi-step tasks and being able to iterate and talk to itself and create this feedback loop that it can keep acting on, it can also connect to external tools now, which is really what's enabled this big transition into a useful coding assistant. Because before, you tell ChatGPT something, it's not like it can push a button on your refrigerator if you tell it to give you some ice or something. Right. But with some of these new agentic AI tools, some of the most prominent ones being Claude Code and Google Anti-Gravity powered by Gemini, they are able to tap into your command line, your terminal, which effectively lets them control the entire computer. You can also give it database connection strings, API credentials, things like that. So it can reach out into other parts of your system, other parts of the world, to not just gain context, but actually take action. And that's what's been, the big thing lately.
Throughout that entire thing, you kept bringing up the term tool. And that's exactly what this is a tool to do these things. If you need to generate, a benchmark or generate some quick script, it's nice to use AI to do those quick one-off things that don't really affect maybe the entire business logic of your application, but it's still something important. You want to find out what algorithm performs the best, try to find slow database queries. It's great to use these tools to do that. But when it comes to the actual implementation, you really need to understand what it's doing, review the code it's generating, making sure it's secure. There's still a lot that goes into it that, many people might not think about.
That's a great point. And it's kind of this big dividing line between a vibe coder and a software engineer who uses AI as a tool in their toolkit. To me, they're such different things that I almost don't even like talking about them in the same scope. Vibe coding to me it's great in that it gets people excited about programs, but it's also terrible in that they may never know what's actually happening. They might not understand what's being built. And in the end, there's always going to be a dire need for people who do understand what's actually being created, how it works, what to do when it goes wrong, and so forth. And if you're just vibe coding some app on your free time and it's fun and you want to pass it around to your friends, that's awesome.
Yeah, that's very cool.
It's cool that that's happening and that's become a real thing you can do. But it's not cool that people will build, a little side weekend project, vibe coded, be like, I don't know how to code. I made this. You guys are toast. No, dude, this is not how it's going to really work. And then there's famous examples of some people trying to turn it into a real SaaS product and immediately getting blown apart. Their entire database exposed, no security in place. Racking up server fees. They don't understand system architecture or hosting infrastructure. Suddenly they have a $30,000 database bill and they're like, what did I do? And dude, you vibe coded. That's how that works.
Yeah. And I think that also goes back to just what makes software engineering interesting. It's kind of solving the problems that's interesting. Coming across a really hard problem and trying to solve it is, that's kind of why I got into software engineering. And these AI tools are cool, but if you're using them to do all of that, 100% of, hey, solve this problem for me, I don't know, for me, that takes away, a lot of why I got into software development and engineering to begin with.
Same here. But I also don't think that's a good argument against AI. I agree. It's a personal thing that it's hard to step outside of. You want to protect it. You've done this thing for your whole life. You care about it deeply. You've made it your craft. And now it's a threat of somebody taking that away from you. So we always challenge each other, you and I in particular, to think outside of our emotions and try to decide what's really going on, see how we can adapt to it. Is it cool? Is it better than I think it is? Whatever that might be. And we're learning as we go. But, there's a whole world of senior software engineers out there who just hate AI because it's a threat to their livelihood. And I get that. But there's a lot more to discuss. There's good and there's bad.
I agree with you. And I do think it's a great tool to use. And, it can definitely help, speed things up, do some of the, less important tasks, like I mentioned before, I do think it's a good tool to use.
So let's talk about the senior engineer for a minute, which is us. So we've been doing this a very long time. And because we're a software development agency, and we both have done software engineering outside of Cypress North as well, but for the past 15, 16 years, it's all been with our agency, which means we're building systems for our clients, which also means the scope of what we build is huge compared to someone who works, in one big enterprise for 20 years. The scope of what they work on is really small because it's to power one business. For us, we have the widest, wildest range of client needs and tasks. We've seen it all. I guess in software engineering and with AI, a big point is that writing the code is not the hard part.
Yeah.
It's designing the code to solve a problem. It's designing the system, but actually typing the syntax, computers are perfectly suited for that. Like, it's way easier for AI to understand syntax than it is English language with nuance. You know what I mean?
Yeah. Yeah, exactly.
So that's, I think, an important and big point with this whole discussion is that there's no debate. Writing code is not the hard part of creating software. AI is good at writing code, and we should use it to do that.
Yeah.
So there's going to be this transition where the good engineers, the experienced ones, are going to become more of an orchestrator than a code writer. They're going to become a code reviewer, an architecture designer, a code planner for these agents instead of doing that plus actually typing the code or handing it off to other developers to type the code with your requirement stock.
And I also think too, working at an agency where we're working with other organizations that have their own, business needs and business requirements. I don't think AI is a great tool to be solving those kinds of problems. That's more of like a human to human thing of, understanding a business problem, why it's actually, there's certain business requirements. But like you said, in terms of actually writing code to, solve a problem, the AI is great at, understanding the syntax, applying the syntax. It's a great tool that we can use to speed things up.
Yeah. And so you touched on 2 points. So we already discussed what's the easy part. That's writing the code.
Yeah.
What's the hard part? If you've ever tried to gather requirements for a brand new project inside of a business before, you know how difficult that is just because of humans. That's how humans work. They have a vague idea. They don't really know the details of how they want to accomplish it. It's a big picture goal. Like, I want to make a cooking app that works on my refrigerator touchscreen. Like, okay, you can't tell a computer you want that and have a good outcome. There's all kinds of human-based business review that needs to happen to kind of draw out what really makes sense. What do you really need? What might you not actually want or need ever?
Yeah.
And, gather this from a group of people who are probably not going to all be present at once. It takes a lot of time to get through all of these steps and draw out what it is you're actually going to create. You can't use AI to do that. This is like a person-to-person thing. And, it's not even really an engineering problem at that point. Yeah. Just the business requirement, business goal setting is step one to creating a new system. And then when you get to the part of like drilling down into technical details, you need an experienced software engineering team or person or, whatever the scale calls for to help you work through what's feasible, what are the good, better, best options, how much is it going to cost to run this thing, like what is the scale of it? Are we talking 100 users or 1 million users or 1 billion users? Because they all have entirely different strategies for accomplishing it. And then you have to also know, how do you actually deploy this thing? What is the underlying architecture that's going to power it? How do we connect all of the different pieces that make up a globally redundant, highly scalable system if that's what you need? And AI doesn't fit into any of that. And the only real place that any profession fits into it is a senior software engineer, an experienced software engineer. And that's not going to change. I mean, do you see like any way that is going to go away?
No, and I mean, even thinking about some of the things you just mentioned, as soon as something goes wrong, what do you do if all you know is talking to the AI agent?
Yeah.
Could it solve it? Maybe, but what happens when it's like a mission critical? Hey, we need this up, within the next minute. This has to be back online. You don't have time to wait. But if you have someone that kind of understands the core code base and understands where some of the issues might arise or some of the weak points, you have someone that can immediately start diagnosing and solving the issues. And not that you can't also use AI, that person could also be using AI to try to find those weak points. But without that human there that, can immediately work towards a solution, you're going to be kind of out of luck.
Yeah. And really, I don't think it's the case that AI could help you solve these issues a lot of times once a thing is actually live in production. I mean, there's so much to get into about like our experiences and what we've done, but John and I have run our own data centers together, housing hundreds of clients and running enterprise software globally for huge companies. Commonly, when there's a major problem in production, it's not the code. I mean, I would say very rarely is it the code that's causing the problem. And then there are all these different areas that if you don't understand from head to tail what makes up an application, you'll never find the problem. Because as we've seen, there's things down to like the network transport layer.
Yeah.
There's, DNS issues. There's a web application firewall throttling requests that you didn't realize. The AI is not going to be connected to these things, at least not yet, and probably, not likely all of them ever. They won't be able to fix them. They might help you diagnose them, but you need someone who can see the pipeline of what makes an application flow from the very beginning to the very end. And that is just not possible today with AI. May never be possible, but who knows? And, I think that's critical. Like, it's not going to save you in a time of crisis today.
Yeah. Or even just thinking about, a system that's interacting with many other systems, which, we do that all the time. One of those systems gets updated, but, someone didn't tell us. And it's like, yeah, like how is AI going to solve that issue for you?
And that's another great point about like what AI can do and can't do. And as you and I know, we've worked with certain clients for over a decade, still going. The domain knowledge that we've built up about that company and how their global operations run is really second to none. Like, we've been around longer than most of their own employees have with normal turnover and things like that. We are carrying the legacy of decades of experience and internal systems, of which there are thousands. And we know how they interconnect. And in most cases, what are we looking to do in the future to expand an effort we're doing today to leverage it again in the future for a different area of business? How could an AI know all of these different things when there are systems that are, completely disconnected without having all of that business knowledge? It seems impossible. So when we're designing a new system for this company A, let's call it, we are taking in all of that experience that we have to design the solution that's best for them, not like an out-of-the-box standard solution for the problem. It's like, we know we're going to need this because regional company A, B, and C are also going to need to leverage what we're doing. So we're going to build in conditions that allow them to be folded in later, but they can't do it today because they have data cleanup issues and whatever else. Like, it's this whole human experience and business experience and domain knowledge that makes you a valuable software engineer. It's not typing the code.
Exactly. And even thinking too about some of our clients that have legacy systems where it's like there's no real way for the modern AI tooling through like a model context, protocol or something to interact with those legacy systems. So in that case, like, you can't even really use AI in those situations. You could if you update those legacy systems, but then that's a whole nother conversation about, costs to update those systems. What is the downstream effect of updating a system? It's a very complicated issue.
It is, and that's a really good topic, because with all the advancements in technology over the last 40, 50 years, some of the most in-demand developers in the world are COBOL developers, because all of the underpinnings of our whole society, the banking and financial system, have never upgraded their systems with all of the modern technology because it's just too difficult. It already works. It's too critical. And I think there's always going to be cases like that. So I don't see the profession going anywhere for people who have experience like we do and people who are close to having that type of experience.
Yeah.
So shifting from there, there's this idea of the junior gap, they're calling it, where we've already started to see this happen. Companies overreacting to the AI hype or just using it as an excuse for cost cutting and eliminating entire junior developer departments in favor of AI instead. That causes several issues, one of them being it failed basically pretty quickly, and they're already reversing course, admitting they were wrong, and rehiring people where they can. But the bigger issue is that there's going to be this labor shortage for engineers into the future because we're not training up junior people to become senior people, the way everyone kind of has to. And the way you build a good engineer is by being a junior engineer and being in the trenches and being in trouble and figuring your way out of it.
Yeah, I mean, we've all been there at one point.
Panic, pure panic.
It builds your character, it builds your skills. It's important.
There's in my opinion, no better way to learn than to have your head on fire in a critical situation where you have to figure out what's wrong and why it happened and fix it. And once you do, you know something better than you probably ever would have known it before, because you had to go deep to figure out what was actually going on. And that's what we're kind of at danger of losing with this junior developer issue. We need to kind of invest continually in new talent and continue to bring up new developers, because like we discussed before, the need for good engineers is not going to go away, in my opinion or view. And it's only going to become more important because there's going to be fewer of them. Only the best ones are going to be the most valuable. And we need to create more really excellent engineers. And you can't do that if you don't give anyone the opportunity, because the low-level bricklayers are being replaced with AI coders. Eventually, you're going to run out of the middle and the top for engineers.
Yeah. And I think what you just said kind of highlights a theme throughout this entire conversation where, it's using AI as a tool. Like these junior engineers, should absolutely be using AI as a tool, but it's just one step of the process is, maybe you come across some, critical error and you need to use AI to help you find it and, maybe brainstorm some solutions, but understanding why something failed and then the solution, why the solution fixes that is, critical to developing your skills as an engineer.
Yeah, it's going to probably be at least a short to midterm crisis of mentorship for these junior developers. Yeah. What people are going to be looking for is junior developers, if they're hiring them, who are good prompt engineers, who know how to talk to AI to create the boilerplate code that we might need. Because typically when you are very junior entry level, you come into a task, a more senior person will carve out a small piece of a project to give to you that they know is not that complicated, but they want you to learn, they want to see what you can do, work your way through it, and then give you the feedback and the mentorship to say, here's why you wouldn't do it this way. Here's another option you could do, or 3 options, like research these and see why you might use them. And if we don't continue to do that, I mean, we're really going to be in a rough spot with the talent pipeline in, not that long from now, 5 years, 8 years or so. It's going to become a problem that we're not going to know how to work our way out of. So I think there's kind of like a responsibility by companies to keep the pipeline going. You need to start people low and you need to grow them up through mentorship. Even if you need to manufacture strife for them, like create struggle they may not have to encounter. That's the way you learn how to become a real engineer, is through solving these problems.
Just being able to problem solve. And, that's a skill I've had to build throughout my career. And I'm still building now, even as a senior engineer. And, without, if we just solely rely on AI to solve problems, I don't know what that's going to get us in the long run. And, that gap is going to form.
Yeah, I mean, really, it's a great time to be a problem solver. Like using AI to help accelerate your projects is all about problem solving. You need to know what you're trying to achieve so you can tell the AI to do it. Yeah. Because really what it's best at is mechanical repetition and iteration. It's not good at thinking, like it's not actually thinking. And there's a lot of thought to be had when you're creating these systems. As a human, when you're building something large, you're holding hundreds and hundreds of pages of code in your head, understanding and like mentally wiring things up in your head while you're working on like crafting this thing. The AI doesn't have that type of brain currently. It can load certain amount of pages into context, currently not that much, but it'll probably keep increasing. And it only gains like a basic understanding of the patterns that are already there and can help work inside them. But it can't know all the other things you're considering in your head, like the other conditions that you have to factor in, business edge cases, of which there are a trillion in every single project. Edge cases are terrible for AI.
I think edge cases are terrible for humans too. We come across them all the time, and something brand new that you would never think of, you come across. But
maybe that'll be a benefit of AI is we'll have to simplify things into the most direct route.
Yeah,
that would be good.
Yeah.
So anyway, all that to say, I don't think that it's not over. We're not dead. The software engineering profession is not dead, but it could be at threat if we don't nurture it and take care of it, starting with junior devs and bringing them up alongside AI as the tooling continues to improve and we keep using it more.
I like to think of it, as we've been saying this entire time, as a tool. And like for a woodworker, a table saw is a great tool, but a table saw doesn't replace a woodworker. It's just a tool that they can use. And I think, similarly, like I don't want to sound negative about AI or sound defensive towards it because I'm an engineer. It's just a tool that we can use. It's not something that's going to replace us.
Yeah, exactly. And could you, as a woodworker, continue to survive as a woodworker without a table saw? Yeah. Probably, but the other guys who learn to use the table saw as well are going to do a lot better than you are.
Yeah, exactly.
Yeah. So that's a good way to make an analogy there. So moving on from the topic of senior devs, junior devs, just some thoughts on where I see the AI going in 2026 and probably beyond that. But I think the shift is kind of already happening, where there's this concept of sovereign AI. Companies are kind of losing the cool factor in their minds. Like 3 years ago, it was like, oh, this is so cool. We have to use it. I don't care how we use it. Let's just use it. Today, they're seeing that cool factor wear off, and rightly so. And now they want value. They want ROI. They want to see, okay, this is cool, or, it seems cool, but it's not actually doing anything to help our business or our staff or help us be more efficient or make money. How do we make money with it? And it's becoming apparent that there's going to be this big surge in small language models where companies are using these more refined, purpose-built, smaller models. They're not made to know the whole world like ChatGPT is. It's made to know your business specifically. And you can train these models on your own data. So big enterprises are going to start to create these small models that are trained on their own proprietary company information, deployed to their own private cloud, not leaking any data out, into these public models and running them internally to do exactly what their business needs it to do, not some, just giant hammer like OpenAI is. And alongside that, there's going to be a big focus on security and governance in these AI models. There needs to be way better controls, way more source citation in the information it's providing, way more governance on the data that it's reading and how you're controlling access to it and what can be used and what can't be used. And same with once you start enabling more and more tools through some of these agentic AIs, restricting what it can do, because it's still a wild west out there. Yeah. There's a trillion different tools out there. And every day you read about somebody whose agentic AI deleted their entire root directory or the whole project or deleted their GitHub repository or the database. Yeah. And we can't be having that. So there's still a long ways to go. But internal company private AIs is where I see things moving as far as, B2B style corporate use cases where they're proving value or getting value out of AI in some way. Okay, so that was a lot of information all at once about where we think AI is going, but hopefully you found some of it valuable.
Ultimately, we're still going to need engineers to make engineering decisions. And that, that includes understanding the complexity of a problem, coming up with, various ways to solve it, understanding the trade-offs of all those different ways to solve it. And that, to me, is, the exciting and fun part about software engineering, is working through those problems, working with the team, brainstorming with other people, brainstorming with your AI tooling. You still need the engineer at the core of the problem to work through it.
These are just our opinions, and we'll wait to see what happens in 2026 and beyond. But the final note and the final message here is that software engineering is not going away. We are going to need good engineers more than ever, and we need to make sure that we bring up junior engineers to learn the craft and learn how to work together with AI alongside our senior engineers to become great assets towards any company to help prove value and use AI together.